Pre-Algebra, Mr. Lawrence here with your flipped lesson, and I want to clarify something that I confused you with. I made it too hard today, and I apologize for that. We're talking about events that cannot happen at the same time. Those are called non-mutually exclusive events. Mutually exclusive means they cannot happen together. For example, if I roll a six-sided die, it is not possible to roll a 1 and a 6 on the same roll. It's not possible. However, it is possible to roll a 1 or an odd number. The first case would be mutually exclusive. To roll a 1 or a 6 would be mutually exclusive. You can't roll both on the same roll. But the second one, to roll a 1 or an odd, well, 1 could happen, but 1 is also odd. 3 and 5 are odd, but 1 is both 1 and odd. So those are called non-mutually exclusive, and that's when we have to do a little bit of subtraction. Now what I want to clarify for you is, I should have done this differently. I wanted the probability of being heads or a 5. I'm going to put a check mark in every box for the heads. So I'm going to look at my coins. These are my coins. I could get a head or a tail, and I could get a head, I win, head and 2 I win, head and 3 I win, head and 4 I win, head and 5 I win, head and 6 I win. Okay, now I'm going to look at the die, which these numbers represent the die. All right, so I'm going to get a 1, 2, 3, 4, 5, or 6. Now I'm only going to win if I get a 5, right? Those are all the ways to win, except there's one problem. I put 2 check marks in here. I don't want to do that, so what I need to do is I need to subtract off one of these check marks. When I go to actually do this problem, I'm going to figure out the probability of a head, which on a coin would be 1 out of 2, or means add. So I am going to add the probability of getting a 5 on a 6-sided die, 1 out of 6, but then I have to subtract off 1/2 times 1/6, because that gets rid of the overlap, the 2 check marks. I only want 1 check mark in each box. All right, now if I turn 1/2 into 3/6 and 1/6, and then this over here becomes 1/12. So right now I have 4/6 minus 1/12, and I could play my little denominator game. Take the larger of the 2 denominators, and I'm going to count by that number until I get a number that the smaller denominator goes into. 12. Stop! 6 goes into 12 2 times. I'll multiply by 2 there, and my new fraction will be 8/12 minus 1/12, and I will get 7/12. And there it is. Now let's check this out. Let's go up here and count our check marks. All right, 1, 2, 3, 4, 5, 6, 7. How many total boxes are there? There's 12. 7/12. You see how that works? All right, let me see. Let's go up to here, and we are going to try to figure out the probability of a number less than 6 or a prime number rolling a 12-sided die 1 time. Well, let me list the numbers less than 6 on a 12-sided die. I could get a 1, a 2, a 3, a 4, a 5, right? A prime number on a 12-sided die, well, that could be a 2, a 3, a 5, a 7, or an 11. Did you hear me repeat myself? I sure did. I said the number 2, 3, and 5 on each side. These events are not mutually exclusive because I could get, if I get a 2, it counts on both sides. It counts as being a number less than 6, and it also counts as a prime number. So to do this problem, here's how you do it. This is really easy stuff, guys. What is the probability of getting a number less than 6 on a 12-sided die? Well, there are 5 numbers less than 6, and there are 12 total numbers on the die. Or means to add, and then the prime number. Well, there are 5 prime numbers on a 12-sided die. But since some of them happen in both categories, both number less than 6 and a prime number, I will subtract off 5/12 times 5/12. Okay, you take both fractions and add them, take both fractions, multiply, and then you subtract them. Okay, so this will become 10/12. This will become 25 1/44. Now, if I pay attention to my own work here, I know that I could multiply this by 12 and that by 12, and I'll end up with 120 over 144 minus 25 over 144, which will end up being 95 144th. That's the probability of those two events happening. Okay, one of those two events happening. See, I got to subtract off the products, the multiplication problem, because I don't want to count the 2, 3, and 5 twice. All right, let's say we have this bag of letters. All right, I need the probability of getting a letter or of getting a blue. Okay, well, let's see here. The probability of getting a letter, it looks like there's A, B, C, D, E. So there are 5 out of the 8 characters in the bag are letters. What's the probability of getting a blue? Well, I could get a 3, a 2, a 1, or an E. So that would be 4 out of 8. Did you notice, 4 means that, did you notice that I underlined E twice? Do you see that? That's a hint that I'm going to have to subtract off 5/8 times 4/8. Whenever at least one of the things we're counting ends up in 2 different categories on an OR problem, then we need to subtract off the products. All right, so I'm going to add these two together and get 9/8. I'm going to multiply these two together, and let's see, that's going to turn into 1, that's going to turn into 2. Looks like it's going to be 5/16. All right, Stash, you ready? I'm going to play my game. My game says to count by the larger denominator until I get a number that the smaller denominator goes into. Ready? Get ready to yell at the screen, Stash. 16. Stop! Okay, 8 goes into 16 2 times. I'll multiply by 2 there, and I'm going to get 18/16 minus 5/16, which will end up equaling 13/16. And that's the probability of reaching in one time, grabbing a letter, or grabbing a blue. Okay. Did I make the same mistake twice? No, I'm okay, right? Hold on one second. Okay, I'm going to have to think about that problem. Something about that is bothering me. All right, let's see here. Let's do the probability of getting a red or a number this time. Well, it looks like there are 4 reds in there. So the probability of getting a red would be 4 out of 8. The probability of getting a number would be 3 out of 8, right? Because there's only one drawn. Okay. Now, let me ask you this. Is it possible to get both a red and a number? Well, let's see here. A is red, but it's not a number. B is red, it's not a number. C is red, it's not a number. D is red, it's not a number. So none of those do it. E is not red, not a number. Won't count it. 1 is a number, but it's not red. 2 is a number, but not red. 3 is a number, not red. So no, it is not possible. That makes this problem easy. I don't need to do the subtraction thing. All I need to do is add these two fractions and get 7/8. And if you look at it, it makes perfect sense. I'm going to come up here and highlight everything that is either red or a number. 1, 2, 3, 4, 5, 6, 7 out of 8. Okay, let's see. I think I might have another example here. Let's see. In a standard deck of 52 cards, okay, there are 4 suits: hearts, diamonds, spades, and clubs, and each suit has 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, king, and ace. All right. I want to know the probability of getting a face card or of getting a heart. Well, let's see. There's 1, 2, 3 face cards in 4 different suits. There must be a total of 12 face cards. 4 kings, 4 jacks, 4 queens. There's a total of 52 cards, right? Okay. What's the probability of getting a heart? Well, a heart looks like it's 1/4 of the deck. 1/4 are hearts, 1/4 are diamonds. Okay. Or you could say it's 13/52, right? 13 of the 52 cards. Or means add. Now let me ask this. Is it possible to get both a face card and a heart? Is it possible? Can you name a card that is both a face card and a heart? How about the King of Hearts? The Queen of Hearts? or the Jack of hearts. Sure enough, they are all face cards and hearts. So because of that, I'm going to have to do my little subtraction thing. I'm going to subtract off 1250 seconds times 1350 seconds. Okay? So I'm going to add these two together and get 2550 seconds. And then I've got to multiply here, and I know this is going to turn into 1/4. I know this, if I divide them both by 4, I'm going to get 3/13. I don't think anything else will simplify. I'm going to get 2652. And I got lucky there. That will subtract down to 2250 seconds. And there we go. All right, 2250 seconds. That's how simple this is. All right, tomorrow I'm going to expect you to be able to do a problem, say like this. You need the probability on a 10-sided die of getting a number less than 5 or a number greater than 10. And then a second problem would be the probability of getting a number less than 6 or an even number. Okay? Well, let's see how to do these. The problem, you're not going to do these exact problems, but something just like this. All right, let's see here. Probability of getting a number less than 5 would be, let's see, 1, 2, 3, 4 out of 10 numbers, or means to add. Number greater than 10, there'd be 11 and 12. There'd be 2 out of 10. It would be 6/10, which would simplify to 3/5. Okay. I don't have to do the subtraction thing because it is not possible to get a number that's less than 5 and greater than 10 at the same time. If you think it is, name me the number that is both less than 5 and greater than 10. All right. If I need a number less than 6 or an even number, well, let me see here. A number less than 6, there'd be 5 out of 10 on a 10-sided die. An even number, or means to add. An even number, I think that would be 5 out of 10 again, except numbers less than 6, 2, 3, 4, and 5. Even numbers 2, 4, 6, 8, 10. Look at this. 2 is both less than 6 and even. 4 is both less than 6 and even. It's getting counted twice. All right, let me get rid of that because I goofed. There we go. That looks a little better. So this one I will have to subtract off 5/10 times 5/10. Now, I know that this is going to be 1/2 plus 1/2, which is 1 whole. And this is going to be 1/2 times 1/2, which is 1/4. And I will get an answer of 3/4. And there you go. All right, Mr. Lawrence signing off. Have a good night, everybody.